So today on the bench, again, yet another black box radio. And I'm really getting tired of these. I just don't like these radios. But yes, it's a Cobra 200 GTL DX. Definitely not one of Cobra's better radios. So, customer sent this one in. Now, I'm not, honestly, I can't remember if he said if he has had this or he just got it. I think he just got this, if I remember right. And his problem is it has, well, he said no output modulation. So it has sound coming out of the speakers. The bottom cover is off as well, so the internal speaker is not attached to it. But if I hook up an external speaker to the external speaker jack, receive audio is fine. So I want to cover a little bit more on troubleshooting, how to run through circuits and whatnot. So this one's actually another good example. I have gotten to a point where I've found where the problem is generally located, and I want to run through how I got to that stage. And then we can look at the schematic and see what could be the possible causes of the problem. So the problem is no modulation, and it does not matter what mode it is in. So AM, sideband, FM, even the Roger beep. So it has no audio modulation. Well, no, actually the customer said it had no audio modulation. Actually it does. It's just really, really low. So, if I hook up a microphone, this is a good old USA-made astatic microphone with the gain turned up the entire way. Yes, I can get the needle to wiggle a little bit, let's say. I can get maybe 5-10% modulation. So there is some audio making it through, but it's at ridiculous input levels. So how do you go about diagnosing something like that? Well, now this is a surface mount radio, so for starters, a lot of people are not going to they might like the radio, but they don't like working on them because it's surface mount. So yes, that does make things a little bit more difficult if you don't have the proper equipment to work on these. And obviously someone that probably shouldn't be working on surface mount radios has already worked on this. I can see parts, and I guess they were trying to diagnose the problem with this radio because the electrolytic capacitors, they're just normal can capacitors, through-hole style caps. They have a plastic wrapper on the outside. It's kind of like heat shrink tubing, but it's crinkly kind of plastic. But you can see it's all melted on the side of this one capacitor here. So yeah, someone's been down here soldering on this poor little IC down here. This little, can't remember if that's an NJM or a KIA, but it's a 458 dual op amp. Let me look at the schematic here. Yeah, it's a KIA 458 in these. Yeah, somebody's been down in there tinkering around. There are other capacitors bodged in here for Lord knows what purpose. So yeah, somebody's been tinkering with it, but it's not too bad. But that's the first thing. Anytime you do diagnostics, look for previous work. A lot of times you can look at something and go, aha, somebody was messing circuits in this area. So someone might, you can kind of use that as a roadmap that may lead you to the fault. They may have found the fault and just couldn't find a part for it, maybe, So you can look for, now it's kind of hard on surface mount stuff unless you have a microscope, which is why my microscope head is sitting there on the bench, because, and it's not in the microscope mount because that's what my camera is mounted to. So, but yeah, someone's been messing with the mic amp because that's what that dual op amp right there does. And under inspection with a microscope, and like I say, that you have to have a microscope. There's no other way to see terminals that small and see if they've been touched, basically, than to have a microscope. But yes, with a microscope, I can see someone's been in there with something probably like this, a very pointy probe, and you can see traces where someone's poked into the solder. And like I said, and then again, obviously, melted capacitor plastic. Yeah, someone's been down in there. And the proper way, if they thought that was bad and they needed to change it, you can just look at it. Even even if you don't work on surface mount radios, you would think you would look at that tiny little part down there and realize there's no way you're ever going to get down in there with a soldering iron with all of these surrounding components and successfully remove that without removing some of these parts. And they're easy to remove. That's kind of what makes it silly why someone would even try. These are through-hole caps. Just desolder them. Especially if you have a desoldering iron, something like that. It's going to take you, 5-10 seconds. Just remove this one, this one, this one, and probably that one. Once you take those, and you can reuse them. I mean, you can put them back in. But just take those couple through-hole capacitors out. Now you've got all kinds of room to get down into your parts. So try and use common sense. If there's a part in the way, remove it to get to it. To get to the parts you need to get to if you need to do some solder work. So, diagnosing. So, I want to use, again, and I recommend these to people. I probably don't recommend them enough, and I'm going to start to do, of course I'm going to do my basic electronics course, but I want to try and show troubleshooting in my repair videos of actually diagnosing problems. And if you work on stuff like this, it's something you just don't see on techs' benches nowadays. And honestly, I don't know how in the hell they repair anything without one. A signal tracer. So this is just the probe of the signal tracer. But the signal tracer is right there. So all that is basically a high-gain amplifier. Has a speaker attached. Now this one does lots of other things. It has a built-in output transformer, so if you're working on old tube-type equipment, supply B positive voltages, but we won't get into any of that. Mainly what we're using this for is you can monitor our RF and audio frequencies with this. So I just select with, actually I gotta look through the viewfinder so I see where my finger is in here, but with that control I just select internal speaker. So anything we do with this probe, so if I disconnect the ground, because right now I have it clipped just to kind of cut down on the hum. But you can see, as I bring my hand and touch it, and you can even see the eye tube over there, the eye tube closes. So, be forewarned before we get too far into this video, if you're wearing headphones, I guess, I don't know. I know I've seen people mention, thank you for saying something loud's coming up. I guess if you're wearing headphones, this can be blaringly loud, but when we get into doing troubleshooting using this, at times it can get very loud. So just be forewarned at certain points in here. When I touch a circuit, you may get blasted with audio. But the advantage of using something like this is speed. It's so fast, and it doesn't load down your circuit. That's why I like these old vacuum tube signal tracers. They have extremely high impedance at this probe tip right here. It's a vacuum tube operated piece of test equipment. Vacuum tubes by nature are high impedance devices. So when you attach this probe to a circuit, you don't have to worry about loading the circuit down and affecting it adversely. You can pretty much touch this to anything, and yet, other than making sound out of the speaker, you're not really going to affect the circuit that much. So now, of course, we're dealing with audio. Now this has two different places. So what this probe will do, what this does is, with the signal tracer is actually demodulate. So even if I just hook up to, even the antenna, if I turn my signal generator on and inject let's say if you're on a CB radio and you're on channel 20, 27205, if I inject a 27.205 megahertz signal into the antenna jack here, modulated 30% with a 1000 hertz audio tone, and I touch this probe to that antenna jack, you'll hear that demodulated audio. It's just a diode. It's a simple diode circuit that does that, but you can actually hear that. So that's what's really handy about these. You can go through RF stages, IF stages, and actually listen to the audio that hasn't been demodulated in radio yet. You can still hear it using one of these. Now, of course, we're not demodulating anything here because the problem is the modulation. So we're going to be listening to audio frequencies to start with. But the basics of trying to troubleshoot something like this, you've got two directions you can go. You can start at I guess three. You can start at the beginning of the circuit, and trace through to see where the fault starts. or start at the back end of the circuit where you know the fault's happening and is affecting a circuit, and work your way back to a point where the fault disappears. Or some people start in the middle, and and once you work on radios long enough, a lot of times I don't start at the beginning or the end of a circuit. I'll start because I know a component in a specific type radio is commonly goes bad. I might just automatically jump to that component and test it, just because I've seen so many of them go bad. I know, you get a feeling for things like that after a while. But when you're first starting out, just pick, and it really doesn't matter which end you pick. The end of the output of a circuit or the input of a circuit. So in the case of this one, I'm just going to start at the input. Now, especially when you're working on something like this, surface mount stuff, well, you need the schematic for anything. But when you're working on stuff like this, you really have to have the layout diagrams, and not just so much the component layout diagram, but the circuit board trace diagram. Now, it just happens to be all in one on this, so it shows the component locations, their component numbers, but it also has all of the traces on this side of the board. And then you're also going to want the other side of the board, because that's what makes signal tracing, or actually troubleshooting anything on a surface mount, it doesn't have to be a radio, a surface mount anything device, challenging is pass-throughs. So all of these little dots you see, okay, normally in an older radio, it was a single-sided board. If they needed to get a wire from, let's say, grab something here, pointy and non-conductive, from here to here. So you can see there's a bunch of circuit traces already running right there on the board. But they needed to get a trace from here to here. Well, they could just drill a hole in the board here, drill a hole in the board here, and put a jumper wire across. And old radios, you'd see, not old, but radios older than this. That's all. You'd look at a circuit board, and you can see, especially CB radios, dozens of little jumper wires all over the board. That's what they're doing. They're just, but nowadays with double-sided boards, you see all these little gold-plated through holes here. Oh, every one of these. That's a jumper. So that's what they're, let's say this transistor or a diode, whatever the case may be. I'd have to look it up on a schematic, because yes, diodes in a lot of cases and transistors on surface mount stuff can both be can have 3 tabs on them. But, that little pass-through goes down to the bottom side of the board, and it may pick up another trace, and it may come over to this one, and this one comes back over here somewhere, and it goes to another trace here, and then jumpers, there's another trace on the back of the board that shoots back out over here somewhere. So, saving from having to turn the radio back and forth, back and forth, back and forth, trying to trace out those circuit traces when you're signal tracing, it's really handy to have these diagrams so you can trace. And I've even done on this one, I've even highlighted in red a few traces, because these are suspect traces in the circuit I'm working on here. So I do this, and that's another thing. Get yourself a preacher pencil. At least that's what I call them. Don't ask me how I'm an atheist, but I have lots of friends that are preachers, pastors, deacons. I don't know how it is. I have a lot of really good friends that are religious leaders in their churches, but every single one of them that I know has a preacher pencil. That's why I call them that. It's actually just a multicolored pencil made by Pentel, but they're very popular apparently with clergymen, and they use them to highlight sections inside their Bibles, or whatever they're giving on Sundays when they're preaching. But they also work great for highlighting stuff on schematics, and you'll occasionally see my schematics. They look like the rainbow effect. You'll see red lines and green and blue and orange and pink lines all over the place. Well, that's because I'm doing this right here. I'm highlighting stuff. So in the case of like this radio, now actually I did it on this schematic and this one. All the red you see on here was done by me, but I didn't actually have to do that. Someone else at some point in time has done that, and I don't even know where that's at anymore. It's in one of my service manuals. Someone else had done this at Cobra, I guess, and it was sent out with their service manuals. But they traced out the audio path for echo off and echo on, because that's one thing in this radio. The echo is built into the radio. So unlike most black box export radios that have a separate little echo module, the echo is right there. It's that IC right there. So the echo is incorporated into the radio. But the audio, of course, takes two different paths. Echo on and echo off. Echo off is actually a very easy circuit. You can see there's not much of a red line here. Echo on the other hand, yes, it goes all over the place. So, anything in here could be, affecting the circuit. But that's the first thing you want to do. Do you have echo, or do you have audio when the echo's off and not when it's on, or vice versa? If you have audio in one mode with, so let's say the echo on, you might have audio, but when the echo's off, you don't. Well, that narrows it down. There might be a component, in between here. You can see there's components that might say, aha, well, if that resistor right there is bad, or a capacitor or something that's used in one circuit and not in the other circuit. Bingo, that's an easy way to trace stuff down. But yes, get yourself a preacher pencil and do this. It makes troubleshooting a lot easier. That way you're not trying to find a component on the board, signal trace it, measure voltages or check for a signal, and then you got to come back to the schematic. Oh crap, where was I? And you're trying to trace these black lines. If you've sat down ahead of time and traced out the entire circuit, the signal path, beforehand, it's a lot easier to go, okay, I want to check that capacitor. Come in and check. Okay, what's the next component in the line? A resistor. And you can just automatically come back here and you can, very easy to follow the flow. You've done the hard work ahead of time. Now, like I say, someone had actually done this, I guess, at Cobra sometime, because he's something that looks very similar to this was issued with one of their service manuals one time, and I just did the same thing. I just copied that red line then over to my schematics, because I actually print these out in full size. There's another thing, schematics. I'm trying to work on something like this that has a fair amount of components on it. If you print it all out on a single 8.5 by 11 piece of paper, good luck trying to read it without a microscope, because it's going to be tiny. So now I have wide format printers that print 11 by 17, and then I also have extremely large format printers. They're it's a roll of paper, so I can print schematics that are, well, there's no length limit because it's a roll of paper, but up to about 3.5 feet wide. But even if you don't have access to stuff like that at home, almost every town has a little print, copy, shipping type center. You can go to Staples, Office Depot, places like that. Download the schematic online, put it on a thumb drive, and just go get it printed. It doesn't cost much to get stuff like this printed, and it's a lot easier when you have a large format schematic to work on. And, they can do really good, they might be able to do better quality color printing jobs than you can do yourself at home. So just some advice there. So let's actually get into doing some diagnostics on this. So we know we're missing audio. It's extremely limited, I should say. So of course the first thing you want to check is the mic jack. Start with the simple things. As the connection at the microphone jack is a solder connection broken out. So, flip the radio over here. I'll try and do this all on camera. Not live, of course, it's a pre-recorded video, but I'm going to try to do this all without stopping the video at any time. And this is one of those places where it can start to get loud, because we're going to be using our probe here. So I'm just going to clip onto the chassis here for ground. And then grab my microphone. Go down here and try and get around the camera with my head. I can see what the heck I'm doing. And you can tell how sensitive this probe is. You get in certain places. You can hear the digital buzz. So that's how not even touching anything, just waving this thing in the circuit in certain areas, you can hear the buzz of like the little transformer or the power supply module for the night watch. But Let me try and get down here on pin 2, the mic jack, and grab the mic. Man, I'm just trying to work around this camera is killing me. I can't get my head in there to see anything. There's got to be an easier way to do this stuff with a camera. Okay, and I'm going to grab my mic. Ooh, and turn the gain down a little bit. Audio 1 2 1 2 3. So you can tell we definitely have audio there. And another thing, while we have the radio flipped over in this direction, if we look at our schematic, we can see comes out of the mic jack, comes up over. What's the first thing it goes through? The mic gain pot. So while we've got the radio turned over in this direction, the mic gain pot is right here. So we can check. And it's the center control. The center control is going to be the rear section of a dual control. We'll just check at the wiper. So we can just... Audio 1 2. So we know it's good there. Now, like I say, I've already pre-traced this out, so that comes down, goes to a yellow wire here, which is that yellow wire right there. We just want to make sure that its audio is actually getting down to the board here. We can back probe there. Again, grab the mic. Audio 1 2. So we can tell it's working there. So audio's fine at the mic jack, gets through the mic gain potentiometer, gets down to the main board. Let's flip her back over here now. And now is when we start getting into little teeny tiny components. So, let's see here. Well, I guess it's not too bad of a view. So, it comes up, where did I just put my pointer? Through pin 4. So, 1, 2, 3, 4, that's this pin right here. So, let's just verify that we have audio there. I need to turn on, actually I got lights built into this microscope stand that I'm using. I need a little bit of auxiliary light here so I can see what the heck I'm doing. So 1 2 3. Audio 1 2 1 2. So we have audio there. And that's where the mic gain pot comes down. So we can look for another component in the signal path here, and we have R625. Now, of course, surface mount boards do not have component locations marked on, or the identifiers marked on the board. They may have stuff like cables and whatnot, and some of the larger components. But yeah, unlike through-hole boards, where every component would have like R235 or C62 written beside it. Yeah, the parts are so small nowadays with surface mount, they just don't have the room to do that. So that's where you really, really, really need your board layout diagram. So we want to look for, where did I say that was? R625 and R625. Now, this red line that I had put on this schematic here, so you can see 1, 2, 3, 4, so that's the 4th pin, that's the audio coming from the mic gain pot, can go in 2 directions. Those 2 directions are in this direction, that's echo on, and in this direction, that's echo off. So we're going to be dealing with the echo off because that has the least amount of components, and we know it doesn't work in both modes. So we want to deal with this one because we know it's not the echo circuit causing the problem. Or at least, I'm not 100% sure about that yet, but we know it works. The problem is in both modes. So we can eliminate, I should say, most of the echo circuit components. But we want to check here at R625. So that is that little surface mount resistor right there. See if we have our audio on both sides of it. Audio. Have it on that side. Audio. And we have it on the other side of that resistor. back to the schematic. Next thing, now they have it listed, it was probably a revision or something at some point in time. They have it listed on here as a capacitor. Well, capacitors are not, that's not a capacitor, that's a resistor. So I'm not sure why they did that. Typo, who knows. Maybe it was a capacitor at one time, but yeah, now it's a resistor, and that's actually what's on the board. There's actually two resistors. There's a 1K, and then there's a 2.2K. So let's check the signal on this side, in the middle, and on the other side of these two resistors. And there, so like I said, that was, what, C165 and R240, what the heck is that, 245. And they just happen to be right here, C165 and R245. So that's right there and right there. So again, we'll grab our probe. Now, every time you go through a resistor, don't be surprised if your signal is a little bit lower. Obviously, it's gone through, your signal has gone through a resistor. So it may be a little bit lower in level, but it shouldn't just disappear. So, man, trying to see this. Let me see if I can move the camera back. If I can get this down and over maybe to get it out of my way. Okay, so we'll check there. Audio, audio. We've got signal coming out. Audio, audio. And then the output, that other resistor. Audio, audio. Uh-oh. We have signal on this side, and we don't have any audio on that side. Houston, we have a problem. But that's a good thing. That's what we're looking for, the problem. So we've gotten now to a point in the circuit where we have lost our signal. So actually we don't need to lay out, I don't know, not really. Don't really need a layout diagram at the moment at least. So we have signal, our audio is making it to this point right here, but we don't have anything here. Now, I find it highly unlikely that that resistor would go bad for starters. You know, it's a very low voltage circuit. I mean, the only thing basically coming through there is an audio from your microphone. It's not like there's big, huge voltages or currents being synced through that resistor. But if we look on the other side here, it comes through, and I don't know if you can see that in the camera or not. That's not a junction, but actually that is. There is a little dot right there. So the signal path can actually be going through several components. So there's several things that could be causing a problem. And something we can do is we can leave the radio on because there is no volt. First thing you might want to do is take a voltmeter. Check. Do you have any voltage here? Key your microphone and check. Actually hook the voltmeter up here. If there's no voltages here, then we can actually take a resistance measurement here with the radio on. So let's grab a probe. Just latch onto this can right here for a ground. And I'm going to check for voltage just to be safe. See if there's any voltage here. So, not up high. Ah, damn it. I can never get this meter into... The glare's always killing me with this thing. There you go. So you can see there's only a couple millivolts there. Yeah, and if I key the microphone, which went where it's hanging there, yeah, actually the voltage drops even more. Now, I'm going to leave the probe attached. So where I have the probe attached right now is right, come back into focus, right there. Or right actually at the resistor, but at that point, okay? So I have the voltmeter attached there. So now what I want to do is actually switch it over to ohm meter. We want to check the resistance there. 7 ohms. Yeah, 7 point, yeah, doesn't really matter. That's extremely low. That's our problem. Well, if that resistor was open, that wouldn't be showing a short basically to ground. So apparently we have a short to ground. Now if we look at the schematic again, we can see, remember I said that goes off to several different things. So, excuse me, we can see we have a ceramic capacitor here. Actually that's not connected, so actually that's not in the radio. We have the CW switch here. And we can see that's actually supplying a ground. So when this transistor turns on, it's supplying a ground. So this transistor being directly connected to ground on one side, if it goes bad, it could cause the problem. If we go up, we have other components. If this resistor were to go bad, or dead short, that goes to ground. This capacitor here, if it goes bad, straight to ground. And another transistor, this is our ALC switch. If that one goes bad, straight to ground. Now I actually did a little bit more probing, and if I actually probe, so here is the, I think we're in camera view, this little transistor right here is the CW switch, and then the ALC is actually that one right there, that little guy right there. Underneath my probe tip. That's the ALC transistor. And I would suspect one of those... Whoops. Actually, let me turn that noisy... We don't need that anymore. Turn off the signal tracer. We've traced to where the signal disappears. But, so yeah, if I would suspect a component like a transistor going bad, that wouldn't surprise me. It's rare you're going to find a surface mount resistor a lot of times, especially when a surface mount resistor, if it were to go bad, they'll actually look burned. And all of those look fine. So I suspect, back this way a little bit, I actually think it's this one. And the reason I say that is if I take a resistance measurement at this point, let me get it back on. I'm showing 7.591 ohms. And if I come to this other transistor, actually that's a little bit lower. Maybe it's that one, 7.485. Check this one again. 7.586. Now we're dealing with less than 1 ohm of resistance difference. 7.49, that's actually lower. So maybe it's the ALC transistors bad. And what I'm looking for, because this transistor back here is farther away than this one from this point right here, so I'm looking to see whichever one has the lowest resistance. If I get, let's just make it round numbers. If I had 10 ohms here and 9 ohms back here, well, this one obviously is at a lower potential, so this one I would suspect more than this one, because there's going to be, a little bit of inherent resistance in all these traces and connections in between those 2 points. Yeah, actually, it looks like maybe... Trying to get my probe, make sure the tip's really dug into it good. 7.499 and 7.602. So yeah, it's actually, that one's a little bit lower. So what I'm going to do now is, I'll do this off camera, but I'm going to pull that transistor and see if my basically short to ground. It's not a dead short because it's not like it's 0.03 ohms or something, but I want to pull that transistor, check my resistance here again, see if that path to ground has disappeared. If not, I can just solder it back in. Then I'll do the same thing here with the transistor for the CW switch. I can pull it out. Again, check at that resistor right here and see if my short to ground has gone away. And that's a really quick and easy way to track down which one of these might be bad. You can also do a voltage measurement. maybe the transistor is stuck on. Maybe there's something else in the circuitry that has this transistor stuck on. So, check your base voltage. Is it turned on? Maybe it's not that the transistor's bad, or the same thing with the one back here at the ALC. Maybe it's not that the transistor's bad. Maybe it's just turned on, and it's doing what it's supposed to do. Supply, in the case of this one, supply a ground. And in the case of, where in the heck did it get to, the CW switch here, it's doing its job. When you turn a transistor on, it's going to ground this point. So, do things like that first. Check for voltages, and then if your voltages look fine, they're off when they're supposed to be off and on when they're supposed to be on. And I've actually already checked that with these, and the voltages are fine. So, yeah, that's the next thing I want to do is actually just I'll pull one out, see if it's the problem, and then try, if that's not, I can just tack it back down in, try popping the other one out, and see if the problem goes away. And actually, I may pull this one out first, even though I suspect it's this one. There's a lot of stuff around here I'm going to have to remove. Probably at least 2 electrolytic capacitors to get down into that safely without, have to have some room to work like I was talking about earlier. So yeah, I think I'll try this one first. Be real easy just to pop this one loose really fast, check it, and then if it's not that one, then I'll remove these 2 electrolytic caps and I'll get down in and try that one. So let me get to doing a little bit more diagnostics here, and we'll see if I can actually figure out which one of those is bad, because I highly suspect that's the problem. No guarantees, because like I say, there's other components in that circuit, but it's not uncommon to have transistors go bad. So let me check that and I'll be back. I've figured it out, and I think it's safe to say it was a moron-induced problem in this radio. Butchers, hacks, whatever you want to call them. Okay, so what did I do? We'll get to this little red wire. Red wire is the problem. We were getting a ground here, and there's 2 obvious sources of ground. If either of these transistors is bad, shorted or turned on. I thought I'd measured the voltage on this one. I hadn't. After I turned the camera off, I went back and rechecked, and I did not have voltage on the base of this one, but I did have voltage here. And you can see that it's the ALC switch, and it's hooked up down through the AM SSB sensitivity. Of course, this all feeds back down into the ALC, AMC circuits, or ALC and AMC circuits. So I just did something really simple. I removed this resistor, R183. So if we look down on the board here, that's little guy hiding right there, right beside, in between that. That's another 4558. But in between that IC and this capacitor, that little resistor right there. So I removed that resistor. And when I removed it, we had modulation. So the voltage was, because there's several, that's the only problem. You get to branch points like this, trying to find out what is actually supplying the voltage to this part. You've got several sources. There's double diode packs here. Voltage be coming from God knows where throughout the radio. So if you can find a series component like a resistor here, or or elsewhere in the circuit, it's a real, because chip resistors are very simple to get off. Just tap them with your soldering iron basically, and they're easy to just brush off of the board. So yeah, pulled that resistor out, problem went away. So what's causing that? So I get into tracing out the entire circuit. I get back to the ALC and the AMC transistors back here. And that's when it finally dawned on me, this red wire. Now I know what the red wire is doing. It's supplying voltage, because what it goes to is someone's, pardon my French, but someone's half-assed attempt at putting an LED light, trying to find my flashlight here. But someone's half-assed attempt at putting an LED light in for the meter. So you can see, yeah, it's just kind of bodged down in there, lead bent over, half soldered to the meter board, the dropping resistor, and where that was soldered to is right in the middle of that gigantic glare. There. I'll move the glare spot back here. Right there. So if we just really quickly tack this red wire back in place. Now I have done one other thing. I actually replaced the AMC potentiometer. It was, I actually did one of these not a extremely long time ago. Oh, for Pete's sakes. Again, can't see past the camera here. Okay, so that's back in circuit. Now, I did one of these not too long ago that had a boatload of those trimmer resistors were bad. So I've changed that one, put in a new one. That's this one right here. Actually, that's the AM high power, or AM and FM high power modulation adjustment. So that one has been replaced. But that wasn't the problem. The problem is this light wire. So like I say, I get to looking at this and looking at what it's attached to, and I was like, well, Christ, that's attached into the AMC ALC circuits. And I was like, wait a minute, that's that stupid meter light. So, yeah, I get back, like I say, I'm troubleshooting back here. I've got voltages where I'm not supposed to. Actually, the voltages were way too low. That was the problem. This may not seem like much, just an LED light, but actually, because this LED light is attached to the circuit here, it's drawing down the voltages on this transistor here that are supposed to be at like 7.8 volts, and on one, they're all three terminals are in the 7 volt range is their normal operating condition. They're all down around 5 point something volts. So I was like, what the hell? And that's when, like I say, the light bulb, not an LED, but the actual light bulb over my head went off, and I was like, oh, you've got to be kidding, because I traced, looked at that's where these diagrams come in really handy. A lot of times it's hard to trace these traces on the board and trace that. Sure enough, that's what that light bulb's attached to. The LED light is attached to that transistor there. So with it in circuit, I have it in. I know there's no faceplate on here, but so I can grab it and show you. So there's our mode selector switch. So if we go, full right hand position, that's sideband, and I'll grab the microphone here. And I'm transmitting, and you can see may not show for the glare, but we're in transmit, and I'm talking into the microphone, and if I even turn the gain up the whole way, audio, yeah, there's no modulation. Now, the only thing I'm going to do is take that stupid little wire off. Wait for the tip to warm up here for a second. And we'll just disconnect that. Radio's still on, haven't changed anything yet. And we come back down here, and again grab the mic. Actually turn the gain way down on mic. Audio. What the hell mode am I in here? Audio. And you can see audio. And if we look up at the scope over there, we actually go into AM mode here. Audio. Oh, now I've got for God's sakes, now I've got another loose connection here. Audio. 1, 2, 1, 2, 3, 4. You can see we have modulation. So, yeah. Oh, actually, it's just my mic jack's falling out of the front of the radio. Didn't have it pushed in hard enough. But, yeah. A self-induced problem by somebody. So whoever put this stupid light... Oh, come on, straighten out here, camera. So whoever put this stupid LED light in this radio caused the problem. And you would think, again, light bulb moment, whoever put that light in, if the radio was working when you took the covers off of it, you had modulation on AM and sideband, you installed a light, you put it back together, and you no longer had modulation, maybe the light bulb that I just, or LED in this case, maybe the LED I just installed is causing the problem. But yeah, I guess not. They and this has been apparently to somebody else to look at, and this guy ended up with it. I think he traded sidewalk edger for it. I think that was the guy with this radio. But yeah, I mean, so there you go. There's some troubleshooting procedures, like I say. The audio tracer, signal tracer, our probe over here, is extremely handy for very easily going through a circuit and finding where we have our signal and not. And a lot of times trying to trace signals like that in a radio with something like a oscilloscope can be very, very hard, because signal levels, especially in the beginning stages of like RF circuits, they can be impossible to see with an oscilloscope, because they can be in the sub-millivolt, microvolt range, or just 1 or 2 microvolts. And you can't see them above the noise floor on your oscilloscope. So, tracers like this make it really handy for tracing out circuits. And like I say, it was easy for you to see once we got to this side of that resistor, our audio disappeared. So, yeah. So, there you go. Another radio fixed. Actually had no problems. It just had, I had to remove a moron bodge from it. So, now I'll actually put a light in it the way it's supposed to be, not this half-assed attempt at meter illumination, and do a transceiver alignment on it, and it'll be ready to go. So, I wish I'd have looked at that first. Hey, I found it. Found a problem. It's just one of those things. I kind of broke my own rules. I always say to look for previous work. Well, what the hell? The first thing goes through my head: meter light. What the hell could that have to do with the not having any transmit audio? Yeah, should have known better. There's a moron born every day, and yeah, well, it's this one. We have the moron that did this, decided to tap his voltage source for his light out of the ALC-AMC circuits and completely killed the entire transmit audio circuit. So, lesson learned. Even if it seems to be a completely different circuit, lighting, yeah, even that can cause a problem. So I hope that helps. Maybe some of those troubleshooting tips. And like I say, probably one of the biggest tips I have if you want to work on radios, especially radios, televisions, receivers, anything where you're dealing with audio, voice audio. So it doesn't necessarily have to be a transmitter. It can be a receiver, guitar amplifier, anything like that. One of the handiest tools you can have is an antique, an old tube-type signal tracer. eBay is flooded with those things. I mean, that's a Paco or Paco. I'm not sure how it's pronounced. P-A-C-O. I have several of those. Heathkit made them. I mean, just so many companies had those things. Everybody that made test equipment back in the day made signal tracers. Now, a lot of them won't have this other stuff, which you really don't need. It actually has a watt meter built in. There's a power, you actually plug your device in there and using the eye tube. Like I say, it has an output transformer because back in the day, everything was vacuum tube operated. You had an output transformer for your audio tube, and that's meant, and that was could be a common failure point, was the output transformer. So, it has an output transformer built into it, so you could substitute the one inside of a radio. But really, all you need is basically the stuff that's on that side. It doesn't even need an eye tube. All you need is one that has a speaker, gain control, or actually 2 gain controls. One that sets the multiplication factor, the actual gain controls variables. That's basically your volume control. And then this control over here, it controls all the functions, but you can select internal speaker. Now, one thing to be careful with these types of signal tracers, read the instruction manual. Most all of these signal tracers, you'll notice there's, I don't know if you can even see that, if I can get the camera over far enough to get it to focus on it. But that last knob right there, that last position, it says noise. Well, when you put that thing in noise, there's high voltage on this probe. And what that's meant for finding is leaky, the old carbon composition resistors could start to break down internally, and you get all kinds of crackling noises. You get all just generally weird problems. And a lot of times that's what it would be. It'd be a bad resistor, but you had to have voltage applied to them. And that's where you would use this probe in with the noise feature, and that actually then applied voltage to the resistor. But be careful of that. Don't want anybody to get electrocuted. That's one of those features that if you're working on solid state stuff, you'll never need the noise feature. You don't want to go shoving 100 plus volts into a radio like this, or you'll let the magic smoke out. But yes, so go on eBay. Now, a lot of times you'll find them, they don't have the probes. The probes will be missing. It's the first thing that gets lost with anything. As you can see, I'm lucky. All the ones I have, I think 3 or maybe 4. I got 2 of these, I know, at one auction. Actually, it was a local radio TV repair shop back in the 70s in a local town. I got these at the auction when they sold off the estate. I think I have 2 other ones, though. I think I have 4 of them total. But luckily, all of the Pacos that I have all came with the probes. But if it does not come with the probe, they're very simple to make. You can go online and just look out and look up how to make these probes. I may one day actually make a few. I don't know if I want to say to sell them, but I'm thinking, because occasionally people ask me for a probe body. I actually sent one to Dino for a project he's doing for an RF sniffer probe. But yeah, I may actually make some up. I need to find a company that can, I mean, with 3D printers now, if I get a 3D printer, I could make the end caps. But yeah, there's not much to them. So get yourself an old signal tracer. It can really help track down problems. In the case of this one, it got us to the point where our audio disappeared. And from then on, it was basically just a job of finding out why that was being grounded, what was turning on all the transistors. And it was a chain reaction, basically. That's all it was. Voltage being drawn off of this transistor here was turning on transistor here, and which was then grounding the audio, the microphone audio, way up at the front of the radio. So, but honestly, this radio could, well, it was. I'm not going to say it could have. It was. It was diagnosed with nothing more than a voltmeter and a signal tracer. And you'd be surprised. Back in the day, a lot of techs, man, they'd fix a huge amount of problems in radio. Granted, we're talking vacuum tube days, back when my grandfather had radio TV repair shop and my uncle. But techs back then, man, they relied on these things. Once you get good with actually practical use using these signal tracers, it can replace a lot of stuff. You don't need fancy oscilloscopes. I mean, honestly, you can even, no signal generator, you're just listening for static, you just hook up an antenna. You know, it's just a phenomenal. Now, you're not going to take measurements with this, but you can check stage gains with this just by ear. You can see small audio signal going in or RF signal going in and huge signal coming out. You know, you can just go through. You don't need to take voltage measurements. You can actually hear it through the speaker. So there's just a few tips on troubleshooting, and you saw what was wrong with this one, light bulb. So there you go. Hope that helps.